Hello, Math 120, and this is Professor Gonzalez, and I'd like to do some problems from homework assignment 5.2, and we're taking a look at adding rational expressions, which is basically adding and subtracting fractions that have polynomials in the numerator and polynomials in the denominator. So as you know, when you add and subtract fractions, it's a little bit tougher than multiplying and dividing because when you add and subtract fractions, the denominators must be the same, right? So we've got this step-by-step process right here. So let's take a look at and see how this works. First of all, you want to note that the denominators are the same. That's a little bit large there. The denominators are the same. And because the denominators are the same, we're allowed to add these two fractions. So let's see. I guess I better do this step by step. It says the rational expression in the sum have a common denominator of x minus 5. Add the numerators and write the results over the common denominator. So we've got those. We've got the common denominator of x minus 5, and so that ends up with the result x minus 5 right there. You have to add the numerator, right? So remember, when you're adding the numerator, you must add like terms. So when you take a look at that, we've got what? X squared, 1x squared, and 3x squared, which makes 4x squared. And then we have, right, negative 12x and negative 9x, which is going to make negative 21x. And then we've got a negative 1 and a positive 6, which is positive 5. So you just add the numerator. Now we want to simplify the rational expression. And you know how to simplify this. We have to factor it. So let's go ahead and do that up here. We have 4x squared minus 21x plus 5. Now remember, because of that leading coefficient is something other than 1, we're going to have to multiply 5 times 4 to get our 20. So what multiplies to 20 and we'll add to negative 21, and that's just going to be negative 20 times a negative 1. Gives us positive 20 and adds to negative 21. We go ahead and do this by grouping. So we write down 4x squared, and I probably don't have to do this every single time because we've been doing it quite a bit, but you can see when we have this process here, we have to break the negative 21 down into two pieces, which would be negative 20x minus x, and now we are able to group. Look at the first two group and factor out a 4x. This is going to leave us with x minus 5. Okay, and then the next binomial that we're going to factor out, well, we know that we have to get an x minus 5, otherwise we have to regroup and try again because you have to have the same group, right, when you factor out. So what can we factor out of this binomial to get this grouping of x minus 5? Well, we can factor out a negative 1. Negative 1 times x is negative x. Negative 1 times negative 5 is positive 5. So now you see that common group in gold would be x minus 5, which we just factored out. And then we have left, we have left a 4x minus 1. And you can see, what color do I want? Green. You can see that this x minus 5 is just going to be that x minus 5 that they already factored for us. And so then this also goes down here. So this is 4x minus 1 times the quantity. Apparently they already put a parenthesis in there, and way too much just erased. 4x minus 1 times the quantity x minus 5. It says divide out the common factors, and you can see these common factors are x minus 5 and x minus 5. And so those are common factors that will reduce or cancel, however you want to call it. Probably better to call it reduce those common factors. And what do we have left? We have our 4x minus 1, and there it is right there, 4x minus 1. So that's the procedure. What made this problem easier in some ways is that it already had a common denominator. What made the problem a little bit harder is that after you combine like terms, we had a factoring problem that took a little more work, but not too bad. Let's take a look at number 2. Now they're going to start us off nice and easy, where you identify that you already have a common denominator. And once you have a common denominator, well, then you're ready to add the numerators. The common denominator is x minus 8. And we go ahead and start looking for like terms, like 3x squared and 2x squared. That's going to make 3 plus 2 is 5x squared. And continuing going, we can see that we have a negative 7x minus 35x, and negative 7x minus 35x is a negative 42x. And finally, I've got a negative 2 plus 18, which gives me a plus 16. Okay, so we added. Now, we did the operation right here, which is addition, and then simplify the results. That's what we need to do now. Now, if you take a look at this problem, you might call it a harder factoring problem, but anyhow, they do come up. So notice the 5. So we're going to write kind of out of space here. I think if I go up here, I should be able to pull this off. So how do we do this? Multiply. Jeez, I'm failing. Here we go. Multiply 5 times 16. And so what is 5 times 16? 80. So the question is, so 5 times 16 is 80. So what multiplies, geez, I'm really failing with the colors here. What multiplies to 80 and will add to negative 42, that number in the middle? And so you search and look. If you don't have an idea, then you just start running down 1 times 80, 2 times 40. And actually, that kind of came up pretty quick. 2 times 40 is sounding good because a negative 2 times a negative 40 gives me my negative 42. And negative 2 times negative 40 is positive 80. So then let's go ahead and do the grouping thing. So this is going to be 5x squared. Remember, of course, when we're doing this grouping, we're going to have to replace that negative 2 and negative 40 with our negative 42 that goes in the middle. So let's go ahead and take care of that right now. Negative 2x minus 40x just replaced this blue negative 42x, and I copy down the 16. Now we factor by grouping these two pieces, and the only thing in common is an x. So what do we have left? 5x minus 2. Now with the next 2, I have to get 5x minus 2 for this to work. Is there anything that I can factor out to get that 5x minus 2? Let's see, negative 40. So how about negative 8? Let's double check it. Negative 8 times 5x is negative 40x, and negative 8 times negative 2 is positive 16. Looks like it's working out perfectly. Factor out the common factor of 5x minus 2, which leaves us with x minus 8. So what I did is I just factored that polynomial to the two factors that I just stated, and look at the denominator. It was just x minus 8, which is a nice common factor, and common factors get to be reduced. which leaves me with the final answer, which is just going to be 5x minus 2, right, from up top right there. Okay, number 3, perform the indicated operation. This problem is a subtraction problem, you can see there. But I find that very often students mess up the subtraction problem, so I always recommend to just take an extra step, change the subtraction problem to addition, and distribute the negative. That'll give you the same answer, and it'll just sort of take care of the negatives. So then all you need to do is add. So let me show you what I'm talking about. Actually, I think we have some space just to go ahead and show it down here. So now we have 5x plus 7 up top over x plus 5 plus, distribute your negative, negative x, distribute your negative, plus 9. By the way, this distribution of the negative times negative 9, that's usually where people mess up. But if you do it now, that's where we have a higher likelihood that we're not going to forget it. So now what we have to do is we're going to need to add like terms up top. So you can see I've got a 5x plus a negative x, which of course is just going to give me a 4x. And then I've got 7 plus 9, which gives me 16. This is all over x plus 5. So now our next step is to factor out a 4. And you know, I meant to put this in. I don't think I did that. I meant to put it in MyLab to see how they respond to this. Usually, so you can see that there's a common 4 to factor out. So we factor out a 4 and we have 4 times the quantity x plus 4 over x plus 5. But then you notice that there's nothing to reduce. So both answers would be correct. One is factored and one isn't. Once I factor something out, I usually leave it factored. But MyLab hopefully would give us credit for both of those. I meant to check it and I didn't. But once I factored it, you pretty much want to factor it out so you can identify if you can reduce or not. Anyhow, I wish I would have checked that, but I did not. And I normally do the problem twice, just putting it in 2 different ways, just to give you a little insight on that. Anyways, number 4. Number 4 is asking us to perform the indicated operation. Now, when you look at the denominator, it appears that that denominator, they're not the same, right? But here's the trick here. With this denominator right here, if you can factor out the negative, I'm going to make that negative red. If you could factor out the negative right there, what that does is that changes 3 minus x to x minus 3. And you can distribute your negative, and you're going to realize negative 1 times x gives me my negative x right there, and negative 1 times negative 3 gives me my positive 3 right there. So it's the same thing, but the nice thing about it, whoops. Dang, I'm really losing it all. So when I factored out a negative, I end up with x minus 3. So the thing about this is now I have a common factor. Now, what do you do with that negative? I would recommend putting that negative because, just so you know, when you have, if you have a negative, let's say 1/2, that's actually equal to a negative up top over 2, which is also equal to 1 over, and then a negative in the denominator. All those are equal. They're the same thing. So if those are all equal, why don't we go ahead and take this negative and put it up top here where, you know, in the place where we add and subtract. Don't we add and subtract the numerator? And the answer is yes. So let's rewrite this on what we have here. We've got a 9x over x minus 3 plus a, remember, negative 7, because that red negative went up top. Let me highlight that real quick. We brought the negative up top, so it's up there. And it is all over x minus 3. So without having to really work hard, we have a least common denominator. So now what we're left with is 9x minus 7 up top over x minus 3. Okay. Let's see if I can. Okay, and also just to reiterate something, maybe I didn't. Well, I said it on the last problem, the last homework set, which just talked about simplifying, and sometimes students will see that x and want to do some reducing. But remember, you can only reduce or cancel common factors, right? They have to be multiplied for you to do that. Let's take a look at this next idea, and this is called find the least common denominator. And a least common denominator is the same thing as a least common multiple. Be careful, students mix up least common multiples with greatest common factors. Because the word least sounds like things should be small, but it's the least of the common multiples or common denominators. So they actually get bigger than the numbers you're comparing to. And greatest common factors has the word greatest in it, but they're common factors, so they end up usually being smaller than the number you're pulling from, right? So it's a factor. Factors are smaller. Anyhow, try to get that straight, because that's a common thing. Least common thing to mess up. Least common denominator and greatest common factor. They're different things. So now, what they're asking us to do right now is do a step-by-step of finding the least common denominator. So let's do the step-by-step. It says write each denominator as a product of primes. Basically, what you have to do is factor, okay? So let me just get some color going here so you can see, because they're not always obvious what they're doing here. So we're taking a look at this guy here and writing it here. We're copying this down right here and writing it there. And now what we're tasked to do is to factor that denominator. So essentially, what we're doing here is we're asking what multiplies to negative 45 and will add to negative 4. What multiplies to negative 45 and adds to negative 4? And I'm saying, how about negative 9 times 5 gives me negative 45 and adds to negative 4. Perfect. So this, once again, because this is an easy factoring problem with a little 1 there, all I have to do is factor it down to n minus 9 times the quantity n plus 5, so I don't have to even worry about doing the grouping. Next problem. In this next problem, I'm taking this rational expression and copying it down here, and now what I want to do, I copied the numerator. What I want to do is I want to factor this problem right here, so I will go ahead and we'll work it right over here. Once again, realizing that this has a leading coefficient of 1, this is going to be a little bit easier than it might possibly be. Also, you might notice that it's a perfect square binomial, but you might not. So if you don't, you just write down, okay, what multiplies to 25 and adds to 10? And you're going to find out that's 5 times 5, and that's why this is n plus 5 times n plus 5, so there's 2 of them, so you can just say square. It's a perfect square. Next, find the product of each prime factors the greatest number of times it appears in any factorization. Yeah, I could think of better ways to say it than that way. I think I'm going to show you how to do this in a couple different ways just to try to get more people to see what's going on. Find the product of each prime factor the greatest number of times it appears in any factorization. So basically what they're saying is, for instance, on this problem, we're comparing this denominator and this denominator, trying to find a greatest or least common denominator. Now, the factor n plus 5 is squared here, and it's only to the first power there. So it's saying you have to take the greatest number of times. I think I want to explain this a little bit more in another problem. And then what other factors are missing in our least common denominator? And what's missing is our n minus 9. And that would be our least common denominator. And it says, okay, so therefore the least common denominator of these two nasty fractions is this guy right here. Okay, I'd like to take a little time to talk about this in my own little way. So let me make some scratch paper down here. Get this to add. There we go. We've got another one. So least common denominators are the same thing as least common denominator, same thing as least common multiples. And so let's do this. Let's say you're trying to find a least common multiple, or let's just call it a least common denominator. So let's make it a fraction so it's a denominator. Let's say it's 1/15, and let's make this one, well, let's make this one 2/15. Let's make this one 5/12. So I don't want to add or subtract anything out. What I'm looking for is a least common denominator. So the least common denominator, it has a couple of characteristics here. And one of the characteristics is that this number is a number that 12 will go into without remainder and 15 goes into without remainder. So they go into them, they're divisible by 12 and 15. So but now it's the smallest, it's the least number that will be divisible by the two. That's kind of what's going on. So another way to think about it is to say, well, let's prime factor this, because prime factors actually kind of tell us the nuts and bolts or the pieces that build that number. And this one is just going to be what? The 3 times 4, so 3 times 2 times 2. So let me start off by, let me write it 2 times 2 times 3. It doesn't really matter. But let me start off by taking this, and I'm just going to write it down here in the LCD, 2 times 2 times 3. Now I know that 12 will go into my LCD, is divisible, because it has what? It has the building blocks of a 12. It has a 2, it has a 2, and it has a 3. And so because it has a 2 times 2 times 3, definitely 12 is going into that. Now will 15 go into this number I'm building? Will 15 go into it? What does this LCD have to have for 15 to work? It has to have what? It has to have a 3 and it has to have a 5. We already have a 3. That's where people make a mistake. They throw in another 3 and then it's not the least common denominator. Anyhow, we know that 15 will work because it now has a 3 times a 5. So in other words, 12 works because it has 2 times 2 times 3, and 15 works because it has a 3 times 5, which makes 15. And that's how you make an LCD, or that's what an LCD is. Okay. Now we get into the world of polynomials, not just numbers like in arithmetic. Another rule is actually a little more beneficial. So let's find a least common denominator, or a least common, well, let's make it a denominator again just to stay consistent. And let's let's see, how about 24? So I'm going to have 5/24, and I want to have a common denominator with, let me think about this. 5. Let's make it 10, I guess. Or 18, just to make it kind of interesting. So 5/24 and 7/18. So I'm looking for a least common denominator. Now I can show you the other way, but let me show you this way, which is beneficial, I think, for the polynomials. So what you want to do is you want to do your prime factorization, but you want to write any double or triple roots as powers in exponential form. So what multiplies 24? Well, you could say 2 times 12, and then you say 2 times 6 and 2 times 3. So there's my prime factorization of 24. So write it as exponents. That's going to be 2 to the third times 3. Okay, so that's your prime factorization of 24. Now let's do a prime factorization of 18. Well, that's going to be 2 times 9, and 9 is 3 times 3. So there's your prime factorization, 2 times 3 squared. So when we're trying to find our LCD, the rule is that each unique base has to be in this LCD. So look at when I'm looking at this, I have to have a base of 2. Now, what power do I pick? You always pick the highest power when you're doing this. So this one's to the 3rd power, and this one's to the 2nd power. Oops, I'm sorry, I'm looking at the wrong base. So this 2 is to the 3rd power. This 2 is just to the 1st power, right? So I have to take 2 to the 3rd power. So the higher power is going to win. And then let's look at a base of 3, and let's compare those two. So here's a base of 3. Well, this is 3 to the 1st power, and this one is 3 to the 2nd power. So I have to take the higher power, and that is going to be my LCD. So that works nicely because we're going to have cases where we have these higher powers that we're going to need to deal with and bring in. Okay, so that's a little look of finding LCDs. Let's go ahead and see if we can do some of these problems now. And I'm definitely not where I need to be. Oh, there it is. Okay, so perform the indicated operation and simplify the results. All right. So the good thing here, we're back to kind of something somewhat easy because look at the denominators are the same, 5x minus 11x minus 36, and so is this. So that means we already have a common denominator. We don't need to find that LCD that we did on the last problem because it already is a common denominator, 5x squared minus 11x minus 36, and then we just add the numerator, which is 5x plus 9. Okay, so this is number 6. We added them up. Now the next thing we're tasked with again is, will this simplify? And so I'm going to go ahead. Now the bummer is that it's not easy because, right, we don't have a 1 there. We have to multiply those two numbers and see if we can figure this out. Now the bigger the number, the harder this gets. And 5 times negative 36 is starting to be kind of a big number, negative 180. And we need to add to negative 11. So something that I will do sometimes is I'll just take, because if you start with 1, if you say 1 times 180, you can end up with a lot of factors. That's okay to do if you're not finding it because that's nice and systematic. But sometimes I'll just start kind of hunting for it. And when I see 180, now first of all, let's get the signs, right? One has to be negative, one has to be positive because we're multiplying to a negative number. But when I see 180, I could quickly see that that's 18 times 10 because it ends in 0, right? So now what I've done is I've broken this to a factor of 2. 18 times 10 is going to give me 180. Now I can see, let's see, it adds to a negative 11, right? So I can see that these guys are going to have a difference of 11. And right now, 18 minus 10 is a difference of 8. I need a difference of 11. So another thing that I do, and hopefully this doesn't get too confusing and weird, you could always use a calculator to find factors. But if you're having to do it by hand, let's see if I could use this animation thing. Oh, well. Anyways, 18 is 9 times 2, right? And 10 happens to be 2 times 5. So let's see, I'm thinking of this. Yeah. So I did use the right color. So here's what I want to show is that I've got 18 times 10, which is easy to find. And because all of these factors multiply to my 180, if I take this 2 and move it over here with this guy right there, then I'm still ensured that when I multiply all of this times 9, it's still going to equal 180. So I didn't have to really use a calculator to try to figure out another factor. All I had to do is move one of the factors over. And when I did that, I got 2 times 5 is 10 times 2 is 20. So I got 20 times 9. And 20 minus 9 is 11. So anyways, there's different ways of doing this kind of thing. Of course, you guys are allowed to have a calculator, but it's kind of nice to know these little tricks with factors. So anyhow, we just found our 2 target numbers, and that is going to replace that right there. So I'm going to run out of space quick here. So I think what I'm going to do is, I got you the target numbers. I think I'm just going to go right into factoring it because of space. So this is 5x plus 9, and down below we're going to have x minus 4 times 5x plus 9. So it turns out there are some common factors that will reduce, and we need to reduce them then. So those are common factors. Now don't write the answer as just x minus 4. That's what people will do sometimes. Remember, when you reduce common factors, if all factors are reduced, there's still a 1. So the answer is going to be 1 up top over x minus 4. And there you go. Look at number 7. Number 7 says, find the least common denominator. Here we go. So in order to find the least common denominator, what we're going to need to do is we're going to need to factor. And we're pretty happy that the factoring is not too bad. It has a leading coefficient of 1 there. So let's take care of business with this one. How about if we show our work, or at least show our little work over here. So what 2 numbers will multiply to negative 12 and will add to 4? Of course, I'm getting that from these 2 pieces right here, right? And so what's going to do that? Well, how about a 6 times negative 2 is negative 12 and adds to 4. So therefore, because this is considered an easier problem, it's going to factor down to q plus 6 times the quantity q minus 2. Okay, next one, I need to factor this guy right here, and I'm once again pretty pleased that there is a 1 in front. So then all I have to do is find out what multiplies to 42 and adds to 13. What multiplies to 42 and adds to 13? Well, how about what's 7 times 6? 7 times 6 is 42, and 7 plus 6 is 13. So then we get our q plus 7 times q plus 6. So now we have to find, so remember, let's put a little wall in between them. We have to find the least common denominator here, the LCD. So if we go through looking at, unique pieces here, I see that there's a q plus 6 here and here, but you only need, one will do the job, right? Because when I put in this q plus 6, that will work for both. Okay, so don't put in 2. Both denominators will now, that part of the denominator, q plus 6, will work for both. But now we have some unique pieces, like there's only a q minus 2 here. So q minus 2 must be multiplied with our least common denominator. And I'm also seeing another unique piece here, a unique factor of, let's say, go with this brown color, q plus 7. So that's also going to need to be represented, q plus 7. So our LCD is q plus 6 times the quantity q minus 2 times the quantity q plus 7. All right. Moving right along here. And it says add and simplify. So what you want to do here is rewrite this as 11 squared times x. Okay, in doing so, you can see possibly what's missing. This is add and simplify the so the big thing, the big story here, the denominators are not the same, so you're not allowed to add them. But if you could find the LCD, you could make two equivalent fractions with that LCD, and now you're allowed to add them up. They have to be equivalent fractions, right? You can't just make up new fractions. Meaning, when I say equivalent, this new fraction I'm trying to develop has to be equal to the old one. And then this 6 over 121 over x, that has to be equivalent to this new one also. So we have to basically build new fractions that are equivalent to the old fractions that has what in the denominator? LCD, LCD. So that's what we're tasked with doing here. Whoops, that blew out the whole thing. So first things first is find an LCD. So what is the LCD? I see 11, and over here I see 11 squared. So the higher power must go in, 11 squared. I see x squared and x to the first. The higher power, x squared, goes in. Our LCD is 11 squared x squared. 11 squared x squared. So the question is, what factor is missing when I'm looking at this factor to bring it down to my LCD? And the factor that you should be seeing that's missing is one of the 11s, right? 11 squared is missing. So I must multiply the denominator by 11 to make this denominator equal to this denominator. And how do I make the fractions equivalent? Well, if I multiply the denominator by 11 and the numerator, and the numerator by 11, 11 over 11 is just 1, so it's going to not ruin my fraction. However, it does give me 77 over my LCD, which is a beautiful thing for us, right? We need that denominator to be the same. Why do you want it to be the least? Because we don't want big numbers. That's really the main thing. We do want a common denominator, right? But we want the smallest of common denominators. So we don't have to have these massive numbers that have to be reduced in the end. Okay, now I'm looking at 11 squared. Well, there's 11 squared. That's good. And now what am I missing with this denominator to make my LCD? I'm missing an x. That didn't work. I'm missing an x. So now I have the LCD, right? X times x is x squared. But I must multiply the numerator by x in order for this to be an equivalent fraction. So I multiply the numerator by x, I get 6x. So I'm putting this together. Let's do that. X's first. 6x plus 77 all over 121, which is 11 squared, x squared. And there it is. Okay, on this one, we're going to want to do some factoring, right? So, and okay, remember my recommendation, because over the years, I've just seen too many people mess this up. I always recommend to rewrite this as addition and distribute the negative, which will give you the same problem, the same value. So here's, let's see, space-wise, where can I put this stuff? I guess I'll just put it down below. How much space do I have on this one? Oh, I got okay space. So I want to rewrite this as a plus 5 plus, up top, I'm going to distribute the negative so I don't forget it. Negative 3a, and negative times 22 is minus 22. Oh, darn it. That eraser is just way too big. I was just trying to make that a look more like an a. Okay, now the denominators. We should factor it completely. And so that's just going to be a minus 2. And factor that. Remember, that's a difference of two squares. So it's going to be a minus 2 times a plus 2. So you might be getting better at finding that LCD. What is the LCD here? And you can see the LCD is just going to be a minus 2 times a plus 2. A minus 2 times a plus 2. So when you take a look at this denominator, it already is the LCD, so nothing needs to be done to that fraction or rational expression. It's already the LCD on the denominator, it's good to go. However, this one over here is not the case. What factor am I missing when I look at the denominator and I look at my LCD? I'm missing this factor. So we must multiply a plus 2 to make the denominators the same, and we must multiply the numerator by a plus 2 to make sure that these fractions are equivalent. Now what you want to do here is you want to multiply that out, or some people like to call it FOIL. So when I multiply it out, right, I get a squared, and I'm going to do the middle step in my head. The middle step is just going to be from here. 2a plus 5a is 7a. If you want to take an extra step on that, that's fine. And then we've got 2 times 5 is 10. So here's what we have so far. We have a squared plus 7a plus 10 all over the LCD plus a negative 3a minus 22. Well, we have a common denominator which allows us to now add like terms. So I've got this a squared up top, and I've got 7a and a negative 3a, which of course is going to give me this right here, which is plus 4a. I've got a 10 plus a negative 22, which is minus 12. Down below I've got the LCD, which is a minus 2 times the quantity a plus 2. Now the final question is, will anything reduce? I don't know. A minus 2, a plus 2. There is our indication. It's going to be an easy factoring problem if it's factorable. So we try. We're looking for two numbers that multiply to a negative 12 and will add to 4. What multiplies to negative 12 and adds to 4? And how about a positive 6 times a negative 2, which multiplies to negative 12 and adds to 4? And so that does reduce, or does factor out, and we have some common factors, a minus 2, a minus 2. This leaves us with the final answer. The final answer is up top a plus 6, down below a plus 2. Now, this is going to be tempting to some of you guys. This is nearly irresistible when you look at that 6 and that 2, because 6 divided by 2 is 3. But you better not do it there, because these are terms. What do I mean terms? They're not factors. Factors are being multiplied. They're terms because you can tell, because they're being added. So you cannot reduce. Oh my gosh, a 6 and a 2, that was tempting. What's even more tempting than that? Like way more tempting. I missed it. The most tempting thing to reduce is the a and the a, right? They're the same dang thing. But you better not do it, because they're not factors. They're terms. And if you reduce terms, it will be wrong every time. Okay, so be really careful with that. All right, let's move on to the next problem, number 10. Add or subtract as indicated, then simplify the result. Notice I'm giving a lot more space here because this stuff takes more space. I'm going to zoom in though. Let's do some factoring so we could figure out what the LCD is. And we could start maybe getting a little quicker. What multiplies to 35 and adds to 12? What multiplies to 35 and adds to 12? How about x plus 7, x plus 5? 7 times 5 is 35, and 7 plus 5 is 12. So that factored out. And then what about, what is this, number 10? What about this guy right here? Well, this is a difference of two squares. Remember that this is 7 squared. So I could, and I will, use the difference of two squares to factor that out to x minus 7 times x plus 7. Now what we want to do is we want to build our LCD down here. And I can see my LCD, it's going to have an x minus 7, an x plus 7, and an x plus 5. X minus 7, x plus 7, and x plus 5. Once again, x minus 7, x plus 7, and x plus 5. So then we ask ourselves the question, what is missing? What is missing? I'm missing my pen. What's missing to make the LCD? Well, we've got an x plus 5, an x plus 5, an x plus 7, x plus 7. We're definitely missing this. So we must multiply the denominator by x minus 7. And to keep this fraction equivalent, the numerator by x minus 7. And then we have to multiply that numerator out. And that's going to be x times x is x squared. The middle term is going to be negative 7x minus 4x. Negative 7 and a negative 4 makes a negative 11. X in the middle. And we get negative 7 times negative 4, which is plus 28. Okay, now go to the next one. And I can see that I have x minus 7 and x minus 7 and x plus 7 and x plus 7. I'm missing the factor x plus 5. And when I multiply the denominator by that, I get my LCD, so I'm good. But I must multiply the numerator by that to keep this fraction, this whole fraction, equivalent to this new whole fraction, so they're still equivalent. Now notice what I'm multiplying, a difference of two squares is what's going to happen, right? X minus 5 times x plus 5 is just going to be x squared minus 25. And if you FOIL it out, the middle terms will cancel away, and there you go. So now we have an LCD, and we're very happy about that, because now I can write this over the LCD, which was or is x minus 7 times x plus 7 times x plus 5. Now up top, we get x squared plus x squared gives me 2x squared. And I also have, well, I only have one term, like negative 11, right? There isn't even any x's over here, negative 11x. So negative 11x goes there. And finally, my constants 28 and a negative 25 is plus 3. So now the question is, can I reduce this? And I definitely can write it maybe a little more legibly. So that was x plus, maybe. So the question is, can I factor this numerator so I can then reduce? Well, leading coefficient is 2. There we go again. Every dang time I got to do that at least once or twice, probably more than that. There's a 2 and there's a 3. So we're looking for two numbers that multiply to 6. Multiply to 6 and will add to negative 11. Well, wait a minute. Okay, there's not that many factors that multiply to 6. You know, and you could look at the signs and all if you want, but there's just there's so few possibilities. I don't even think you need to do that. Because 1 times 6 is 6 and 2 times 3 is 6, and that's it. Is there any way I could add or subtract these numbers to make 11? And that's impossible. So this is actually, in fact, prime. It's already factored as low as it will go, and there aren't any common factors, so boom, we're done. Good. Let's move on to number 11. Perform the indicated operation and simplify the result. Once again, big caution here. Just seen it happen too many times. I would change that to addition and distribute the negative. Okay, distribute the negative. Now we need to figure out what our LCD is, and the only way we can do that is by factoring the denominator. So we better do that. So what multiplies to negative 14? I don't know if you guys want your little thing here. We'll do it. What multiplies, okay, by the way, we're very happy to see a 1 there, so it's going to go fast. What multiplies to negative 14 and will add to 5? And add to 5. How about a positive 7 and a negative 2? That adds to 5 and it multiplies to negative 14. So z plus 7, z minus 2. And there we go, a nice difference of two perfect squares again. So we like to see that. So therefore, this is just going to be z plus 2 times z minus 2. Okay, I think we can find our LCD. The LCD, let's see. Let's start with this guy over here. That's going to be z plus 2, z minus 2. We already have a z minus 2. We need a z plus 7. I really ran out of space again. So just rewrite it. Not the whole thing. I'm not doing the whole thing again. There we go. That's our LCD. I'm going to do that again. I've got to build this new fraction with this specific LCD. Can I do it? Sure I can. So we take a look and we see that we have x plus 7, x plus 7, x minus 2, x minus 2. We're missing x plus, not x, z. We're missing z plus 2. We multiply the denominator by that to make the LCD. We better multiply the numerator by the same thing to make the fractions or make these rational expressions equivalent. So we go for it. And we multiply that. Well, z times z is z squared. And the middle is going to be negative 2 times z is negative 2 plus 6. Z is 4z. And negative 2 times 6 is negative 12. So this is number, 11? So we got z squared plus, where do we go? Z squared plus 4z minus 12. Did I make a mistake anywhere? Let's see, z plus 7, z minus 2. Oh, I see what I did. Darn it. So I multiplied the denominator by z plus 2, so I better multiply the numerator by z plus 2, otherwise the fractions are not going to be equivalent. So I caught a mistake, and they're easy to make if you just kind of daydream like I'm doing right now. It happens. So let's see here. Let's try this again. Once again, I found my LCD. I did realize I needed to multiply by z plus 2, but I changed the sign. I must multiply by the same identical thing. Factor, rather, I should call it. Z times z is z squared. The middle term is 2 plus 6 is going to be 8z. 2 times 6 is 12. So that looks better. Z squared plus 8z plus 12. And then over here, we go to identify what factors are missing to make this LCD. I do see an z plus 2 right there. I see a z minus 2 right there. I'm definitely missing that guy. So z plus 7 must be multiplied z plus 7. So this negative sign is just dangling out there. So there's a couple ways to do it. You can multiply this distribution or FOIL, whatever you want to call it, and then change all the signs, because this negatives needs to be dealt with. Or you can distribute the negative right now and then multiply them out. That's what I did last time. I think this time I'm just going to multiply it. I'm afraid people are going to forget that sign if I do it that way. So let's go ahead. Let's focus in on this thing real quick. Let's zoom in on that, because that's going to take some work. I'm going to distribute this negative sign, which gives me negative z plus 2. Nope, I got to distribute the negative sign all the way. Let me show you. Negative times z is negative z, and negative 1 times 2 is negative 2. Okay, this must be multiplied by this green, I'll just copy it in green. This guy right here, which was z plus 7. I'm going to go ahead and take my time. Instead of trying to do it in our head, let's say negative z times z is negative z squared. Negative z times 7 is minus 7z. Negative 2 times z is negative 2z. And negative 2 times 7 is 14. And we add those like terms and we get a negative z squared. Add these guys up to get minus 9z. And we got plus 14. Was it plus? It's minus 14, darn it. Negative 2 times 7 is negative 14. Negative 2 times 7 is negative 14. Good, negative 14. Or plus a negative 14 or minus 14, same thing. So here we are, and now we need to combine like terms. We've got a common denominator. So we go ahead and take a look at z squared plus a negative z squared. Well, that's just going to zero out, isn't it? And let's take a look at what else we have. We've got 8z and negative 9z. Well, that's just going to make negative z. And then I've got, how about this 12 and negative 14, which is going to make negative 2. This is all over my LCD, which is z plus 2, z minus 2, z plus 7. Okay, now you might feel like stopping right here, but if you just go one more, right? Isn't there a common negative? We don't really like to leave that negative out there in front, and here's where it does pay off to think like this, is if you make sure you always factor out negative leading coefficients, this is a leading coefficient, right? If you factor that out, you get z plus 2, and it puts it in a format that you can really compare. We have a z plus 2 down below that needs to be reduced, and it's kind of disguised when that negative is in there. So z minus 2, and then we have z plus 7. So we do have a common factor that gets to be reduced, which is z plus 2 and z plus 2. So now, what you don't want to forget, though, is that is a negative 1 up top. Now, usually the book likes to write answers like this, having a 1 and put the negative sign out front. However, if you left a negative 1 up top, it would not be incorrect, technically. So now we've got a negative 1, and down below is z minus 2 times the quantity z plus 7. And there we go. Okay, and the last problem. What a mess. Okay, well, this one I would recommend trying to use a special formula for. And so we talked about what I think a couple of sections ago. So let's highlight that idea. I'm going to take this and work this problem down here so we have some space to work. So I'm going to copy it down here and factor it. X squared minus 22xy plus 121y squared. So what you want to do here is, the easiest way is to realize that this is a perfect square. And then you want to check, is this a perfect square? 11y times 11y is 121 squared, y squared. So then the big question is this one of those special ones where the middle is negative 2 times your x times your 11y? Let's see if that's true. Negative 2 times 11 gives me negative 22, and we have an xy. That's exactly what's going on right here. So we know that this is called a perfect square trinomial, and this will just save you a lot of time. This is just going to be x minus 11y squared. Okay, so that's what that just factored down to, x minus 11y squared. X minus 11y squared. quantity squared, right? So now let's do the same thing with this one. And I don't exactly mean the same thing because it's not the same problem, but factor it. That's what I mean by the same. Factor it. This one is x squared minus 10xy minus 11y squared. And the thing that makes this one easier is, you guessed it, it has a little red 1 in front of it, which means it's going to be a little bit easier. You do have x's and y's to deal with, so you got to be a little bit careful with that. But this little x, what multiplies to negative 11 and adds to negative 10, still does work though, and you don't have to group because of that little red 1. So what multiplies to a negative 11? We're going to have a negative and a positive to make that happen, and adds to a negative 10. How about a negative 11 times 1? Negative 11 times 1 is negative 11, and the negative 11 plus 1 is negative 10. So now, because of that little 1, we're able to just simply write down the answers. And remember, x times x is x squared, and y times y is y squared. So let's get our numbers in there. How about x minus 11y times the quantity x plus 1y? And so that's what that factors down to, x minus 11y times x plus 1y. So we're going to put that right here. X minus 11y times x plus y. Okay. Now, I regret the space a little bit, but if I run into trouble, I'll just do my little trick with that tool and move it down. So I think I got to do that right now. It just seems like we're a little tight with space. So we will use this little trick, which we did before. Guess not. Okay, I'll do the little trick up here, which allows us to then move this down and kind of out of our way. Actually pulls that. What did it do with that? Oh yeah, I pulled it. Okay. Just get rid of that. Can't help it. Got to show you with that little arrow. So there's that little guy, and this one we changed it so we can see that. That's that. So now we better get an LCD. Stop messing around. Let's get an LCD here. So what's that LCD going to be? Well, x minus 11y quantity squared, this x minus 11 to the first power. We always take the higher power. So x minus 11y, x minus 11y quantity squared, x minus 11y quantity squared. Okay, so that's taken care of. Yeah, we're good there because we at least have... How did I put that square in the wrong spot? There we go, quantity squared. So we're good there, but we also need an x plus y to build our LCD. Now, question. We have an x minus 11y quantity squared. Yeah, we got two of them there. We're missing an x plus y. Missing an x plus y. So we go ahead and multiply that. X plus y times x plus y. What the heck's that going to make, huh? It's going to make x, it's a perfect square, by the way. X squared, the middle term is going to be just 2xy. The middle is going to be 2xy. And y times y is y squared. Let's complete over here. We have our LCD. What is missing to build the LCD? Well, we definitely have our x plus y and our x plus y. We have x minus 11 and one of the x minus 11, right? It's squared, so we're missing one. We need to multiply this by another x, if I can write the right thing, another x minus 11y, right? And then that gives me 1, 2, which is my squared, so it matches up. Now, in order to keep this equivalent, we must multiply the numerator by x minus 11y. So we got to multiply that out. It's a little bit of a messy multiplication there, I guess. So I guess we'll show it right here. X times x is x squared. And x times a negative 11 is minus 11. Minus, what am I at? Minus 11xy. And then what else? Now we've got 10y times x is plus 10xy. You can see these two terms are the same common like terms, so we must add them together. And then we multiply a 10y times a negative 11y, which gives us a minus 110y squared. That's a little scary. Okay, now the middle term is just a negative xy. So this should and does simplify down to, I'm going to put this result right here, and it belongs right in this numerator right here. So this is going to be x squared minus xy, there's minus xy, minus 110y squared. Okay, now we have a common denominator, so we're going to add them up. So let's go for it. Let's see. When we add this up, we add up x squared plus x squared gives me 2x squared. And I've got a positive, got this positive 2xy and a negative 1xy. It's going to leave me with a positive 1xy. And I've got a positive y squared and a negative 110, so that's minus 109. It's quite a term there, squared. And this is all over my LCD, which was x minus 11y quantity squared times x plus y. And I might try to do some factoring here, but this is looking like a bit of a beast here. 2 times negative 109. Well, that's going to give me a negative 218. What multiplies a negative 218 and adds to 1. And I know 218 will factor down to 1 times 218 and 2 times 109. And 109 is prime, so that's as far as that's going to go. There's no way this is going to factor. So this is added together and simplified completely. All right, well, I hope that helped out. That last one was kind of tough, but I hope that helped out, and I hope you have a better understanding of LCDs, which are the same as least common multiples. They're just the denominator. And you have a great one, and we'll talk to you soon. Bye.